Hello, Hornets, and welcome back. This is part two for our pretest. And in part two, we are looking at the second side of the review for Quizzle number 7. And you'll notice that the second side is almost predominantly dealing with derivatives, and so that's what we have to be prepared for. Let's go ahead and start with the first problem. If h of x equals the square root of f of x, then find h prime of 2. Most people screw this one up, so please be aware. Let's follow along carefully. As we are doing this problem, please change that radical into a 1/2 power. That'll allow me to bring the 1/2 in front, and then I have to subtract the power by 1, leaving me with a minus 1/2, and the part that most people forget is multiplying by the derivative of the inside piece. It is with this that I can now plug in the 2. So I'm looking at 1/2 of f of 2. This is to the negative 1/2 power, and I'm multiplying it by f prime of 2. So when I find what is f of 2, f of 2 turns out to be a 1, and we know that the 1/2 power is a square root. So we're talking about the square root of 1 is 1. Multiplied by a 1/2 is 1/2. And then I'm looking for f prime at 2, and f prime at 2 is 4. As a result, I then have 1/2 times 4, and that yields the answer 2. That's what I'm looking for in number 7. Number 8. This is the quotient rule. F prime of 1, g of 1, minus f of 1, g prime of 1, divided by g of 1, the quantity squared. So we're now going to find g of 1. So we find 1. We go to g, and that's 4. That's going to give me a 16 in the denominator. Then I'm going to have f prime of 1 is 2, times the g is 4. That's 8, minus f of 1 is 3, and 3 times the g prime, which is 1, is 3. My answer turns out to be 8 minus 3 is 5, 16ths. Number 9. Number 9 is one of the more tricky problems because you have to remember that if k and f are inverses, the value that they've given you is actually the y value for f. See how in these two problems, the b value of k is the a value of f. So we have to find when f is equal to 3. Go along the column, we find where f is 3, and we locate the 1. This is where we now move into the reciprocal of the derivative of the inverse at b, RDIB, rainy days in Berkeley. So we have the reciprocal, our inverse is f, so we want the derivative of f at the b value for our k point. That's 1. We then go to the chart and we find where f prime of 1 is located. You'll notice that's a 2. And since f prime of 1 is in the denominator, I put it in the denominator, leaving me with 1/2. And that's the answer that I'm looking for. Number 10 is working with the product rule. So we have f prime of 0 times g of 0 plus, for the product rule, f of 0 times g prime of 0. Now I'm going to go along my row where I have the 0 here, and you'll notice that we've got a 2 for f. So wherever there's an f, we're going to put a 2. F prime shows a 1. G is a 3. And g prime is a 4. So all we have to do now is multiply. 3 times 1 is 3. 2 times 4 is 8. We add them together and we get 11. And therefore, k prime of 0 is equal to 11. That's the answer that we're trying to find. This brings us to the second part and our last question A particle moves along the x-axis so that its position x of t in meters at any time t greater than 0 seconds is given by x of t equals the arctangent of 3x plus 1. It is absolutely imperative that you know your derivatives for the arctangent, arccotangent, arcsecant, and the arccosecant. If you don't know those tomorrow, along with the derivative of a to the u and log base a of u, you are at a disadvantage and will have a problem. Please make sure you study them for tomorrow. Now, the first thing that I'm going to need to do is find my velocity and my acceleration. I'm going to go to a separate piece of paper in order to do this. We know that the arctangent of u, when we take our derivative in terms of x, d dx, is u prime divided by 1 plus u squared. Since we're talking about the arctangent of 3x, notice the 1 goes to 0 and drops away completely. We're going to have a 3 in the numerator, and we're going to have a 1 plus 3x the quantity squared. Now be careful because we're distributing the power, and that's going to give us 3 over 1 plus 9x squared. This is our velocity, and if we went to the question B, our velocity at 1, plug in 1, you get 3/10. This would then be in meters per second. Don't forget your units, please. Now, our second step is to find the derivative of the velocity. And we know that the derivative of the velocity is the acceleration. The acceleration can be easily found by just reworking our derivative for the derivative that we found. Change it into the negative exponent, 1 plus 9x squared to the minus first power. From this, we can then work with the chain rule. The negative 3 moves to the front, negative 1 moves to the front, multiplies by the negative 3. We drop the power by 1, and we multiply by the derivative of the inside piece. This gives us 18x. We're then going to simplify. Remember, we had the negative that moved to the front, giving us negative 3. We then have 18x. And this negative 2 power that we get is in the denominator for 1 plus 9x squared to the second power. By simplifying this, we're going to be able to find our acceleration. For our acceleration, we end up with negative 54x divided by 1 plus 9x squared to the second power. A of 1 can now be found as negative 54 times 10 squared, which is 100. This is in meters squared per second. We now have our velocity and our acceleration formula, and we have the velocity at 1 and the acceleration at 1. But we still need the position at 1 to answer all of the questions. After all, question C says, D says, is the particle moving towards or away from the origin? And this requires us to know what is the value of our position at 1. So let's just take a quick peek. Since we're talking about the arctangent of 3 times 1 is 3 plus an arbitrary 1, we can go to the graph of the arctangent. The arctangent has an asymptote at pi over 2, negative pi over 2, and the curve goes in between like so. Notice that every positive value here is a positive above the x-axis. So we know that no matter what value of x that we plug in greater than 0, we are going to get a positive value for our x position. So our x of 1, when we plug in 1, is greater than 0. That means that it's positive. And from that, we now have all the information we need. Let's now go back to our questions. Starting with A, we found our velocity and our acceleration. We plugged in for B, 1, and we found our velocity and acceleration at 1. Our particle moving left or right is based on the velocity, which we saw was positive. Since we have a positive velocity, we know that our particle is moving to the right. And that's what we would write. The particle is moving to the right. And this is because the velocity was positive. Because at t equals 1, v of 1, is greater than 0. A positive value moving to the right. Now we go to D. This is where we need to know that our x of 1 was greater than 0, and we know that our velocity of 1 is greater than 0. Therefore, the particle has to be moving away from the origin because the velocity and the position at 1 are both positive or have the same sign. And I would want to write that down. The particle is moving away from the origin at t equals 1 because, and this is a perfectly reasonable thing, x of 1 is greater than 0 and v of 1 is greater than 0. This brings us to our last question involving speed. Speed works with both acceleration and velocity. Since the velocity at 1 was greater than 0, but the acceleration at 1 was negative 54/100 meters squared per second, or a negative, we know that the speed is decreasing. This is because we are looking at opposite signs for the acceleration and velocity. The speed of the particle is decreasing at t equals 1 because v of 1 is greater than 0 and a of 1 is less than 0. And that's all I need. And that is our pretest, Hornets. I hope this has helped. Please review it if you need to. And remember, if we're working with an arctangent, we're probably going to be dealing with a positive value. So please be aware. If you have any questions, make sure that you come in and ask them prior to the test. Otherwise, I hope this has helped and that you feel more comfortable. Please be well, take care, and we will see you all tomorrow. Thank you very much. Bye-bye, Hornets.